answering section B, only 3 questions from section B. So answer all the questions in this section, write your answers in the space provided. Then question B1, figure B1.1 shows an instrument used to measure the diameter of a piece of wire. So we have a piece of wire being measured, and this instrument is in millimeters. The first question is asking us to identify the instrument. So the screw gauge. We also have the vernier calipers. For the vernier calipers, it measures the length of objects as well as the internal diameter of objects. So we have the micrometer, screw gauge as the answer. So we have the second question, which is question B, which is saying what is the diameter of the wire. So the diameter of the wire, you need to take them from this instrument. So we have this one, which is the main scale reading. So this is the main scale reading. So this main scale reading, one thing that you need to know about this one is that each line represents 0.5 in the main scale. So it represents 0.5 millimeters. So meaning to say that here we have 2, this one is going to be 2.5, 3, 3.5, 4. So in the main scale reading, we have 4 millimeters. Then what about this scale here? So this one is called the rotating scale, or you can call it as the thimble reading. So the rotating scale. So how do you take the rotating scale? So for the rotating scale, you need to take the reading where the line is colliding with the line in the main scale. So we have this line here, at this point here, where it is colliding with the line in the main scale. So if this one is 25, this one is going to be 26, this one is going to be 27. So in the rotating scale, we have 27. Okay? So now, always, you need to bear in mind that you need to multiply the rotating scale with the accuracy. So we have the accuracy in millimeters, which is 0.01 millimeters. So we are going to multiply the accuracy multiplied by the rotating scale. So let me just write here. So final reading is going to be equal to the rotating scale plus the main scale reading. So this is what we have. So for the rotating scale, we have 27 multiplied by the accuracy, which is 0.01 millimeters. Then plus the main scale reading there, it is 4 millimeters. Then when I multiply here, I'm going to get 0.27 millimeters plus 4 millimeters. As a result, my answer is just going to be 4.27 millimeters. So that is our final answer. Then for question C, it is saying state one precaution that must be taken when using this instrument. So when you talk of precautions, you're looking at ways to avoid errors. So what are you supposed to do? So we have these parts here, these parts. So this one is called the anvil. It's called the anvil, and this one is called the spindle. So if you haven't cleaned the spindle and then you try to take the readings, maybe the spindle and the anvil may have dust, which may add to the thickness of an instrument, an object that you are measuring. So the first precaution is that you need to make sure that you clean the anvil. Apart from cleaning the anvil, you need to zero the instrument before taking any readings. Zero the instrument. It should start from 0 before you even take the readings. And also we need to adjust the latchet. So this part here is called the latchet. Okay, it's a latchet. So you need to make sure that you adjust the latchet. So you can choose from there. So let me just say clean the anvil. Clean the what? The anvil and the spindle before taking a reading, right? And the spindle before taking readings. Or you can say you need to zero the instrument or zero the instrument. Whichever way is simple for you, you can just choose zero the instrument. And then for question B2, it is saying figure B2.1 shows a pulley system used to raise a load of 70 newtons when an effort of 35 newtons is applied. So a pulley system, this pulley system is an example of a simple machine. Okay, so what is a simple machine? So when you talk of a simple machine, let me just write that. So a simple machine, it is just an instrument which uses less effort to overcome big load. So let's say, for example, if you have about 4 Siemens, you can't just lift all those 4 Siemens, but you can use you can use a simple machine to carry those 4 Siemens. Like for example, wheelbarrow. Wheelbarrow is an example of a simple machine. You can put your 4 cements there and then you are able to lift them. Okay, so those are the examples of simple machines. So meaning to say that you're going to apply less effort to overcome big load. Maybe let's say, for example, each cement is weighing about 50 plus newtons in that way. So as you can see here, we have the mass here, or the load. So this one is the load, and the effort which was applied here is just less than the load that we have. So the first question is saying, what is the mechanical advantage of the block and tackle pulley system? So here we are calculating the mechanical advantage. So mechanical advantage is given by the formula load over effort. Okay, so we have identified the effort there. We also have identified the load. So the load that we have is 70 newtons, and then the effort that we have is 35 newtons. Okay, so as you can see, the newtons and the newtons, they are going to cancel each other, and then 70 divided by 35, I'm going to get 2.0. So 2.0 is our answer, no units, because it is a ratio. Then the second one, which is question B, is asking us the velocity ratio of the pulley system. So when it comes to the velocity ratio of the pulley system, what you should do is you need to count the number of wheels. So how many wheels do we have? So we have this one, which is the first one, the second one, and the third one. Or if you don't want to count the number of wheels, you can also count the number of loops at this point here. So as you can see, how many number of loops do we have here? So we have 1, 2, 3. So meaning to say that the velocity ratio is going to be equal to 3. No need of you calculating. So velocity ratio is equal to 3. Or you can give a statement if you want by saying the number of wheels equal to the velocity ratio. Then you say 3. So one thing that you need to understand here is that I'm saying that number of wheels, the number of wheels are equal to the velocity ratio. So that is one thing that you need to know here. Then the second one, which is question C, is saying calculate the efficiency of the pulley system. So when you talk of the efficiency, you're talking how much the machine, how effective the machine is. So how effective a pulley system is. So there are also ways in which you can increase the efficiency, that is by applying oil to avoid friction, or by increasing the number of wheels to avoid or to increase friction, or increasing the number of loops or turning. So efficiency, I'm going to say if this one is going to be equal to the mechanical advantage divided by the velocity ratio, then multiply by 100%. Okay, so only an ideal pulley system gives you 100% efficiency. So this is not an ideal pulley system. So meaning to say other energy is going to be lost due to friction as well as due to heat. So we have this one, which is the mechanical advantage, which was 2.0, then the velocity ratio, which is 3.0, then multiply by 100%. So what are we going to have? So we can say 200 divided by 3. I'm getting 66.67, but we can just round off this one to 66.7%. So meaning to say our final answer here is just going to be 66.7%. So this is how efficient that pulley system is. So meaning to say that if we say 100 minus the same answer that we have found, we are going to get 33%. Okay, so in an exam they can trick you to say how much energy was lost due to friction. So what you are supposed to do is how much percentage of it was lost due to friction and heat. The first thing, you need to calculate the efficiency, then you less the same efficiency that you are going to get from 100%, and this is 33% or 33.3%, meaning to say this one was lost due to heat or friction. Let's try to answer the last one, which is question B8. So figure B8.1 shows an electric circuit consisting a battery of electromotive force of 12.0 volts connected to a switch S and two resistors of resistance 6.0 ohms, each connected in parallel. So we have these two resistors which are connected in parallel, as well as the voltage, so electromotive force is also equal to the voltage. So we have the electromotive force, which is also equal to the voltage, which is 12.0 volts. We also have the total resistance. We don't have the total resistance, but we have these resistors, so we can calculate the total resistance. So total resistance, since we have two resistors connected in parallel, we can just say resistor 1 multiplied by resistor 2 divided by resistor 1 plus resistor 2. So this formula is only applicable when you have two resistors connected in parallel. But if you have many resistors, you need to use this formula: 1 over total resistance, and this is going to be equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and so on. So this is the formula when they are more than 2. That is the formula that you're supposed to use. Okay, now let's find the total resistance. So here we have 6 multiplied by 6 ohms divided by 6 plus 6 ohms. So we have 36 there on top, 36 ohms divided by 12 ohms. So 36 divided by 12, I'm getting 3 ohms. So meaning to say that 3.0 ohms is our total resistance. Okay, so now the question is saying calculate the current flowing through the circuit when switch S is closed in R1. So we are calculating the resistance. So you know to say that current is equal to voltage divided by the resistance. So in this case, they have specified that we need to calculate the resistance for R1, which is this one. So the voltage is just going to be the same. So for resistors connected in parallel, the voltage is equal to each other. So this resistor is receiving 12 volts as well as this one is receiving 12 volts. The opposite is true when resistors are connected in series. So resistors connected in series, they have different voltage but same current. Then similarly, the opposite is true for this one. Resistors differs for resistance connected in parallel. So we have the voltage which is 12.0 volts divided by 6 ohms. So what are we going to get? We're going to get 2.0 amps. So we have 2.0 amps as our answer. Then we are calculating the resistance, or let me say the current of the battery. So calculating the current of the battery, we need to combine these two. We need to find the total resistance, which we have already found, then find the resistance and find the current, So current is going to be equal to the voltage divided by the total resistance. So the voltage that we have is 12.0 divided by the total resistance. In this case, it is 3 ohms. So when I divide, I'm going to get 4.0 amps. So that is our final answer for this one. Thanks for watching.